Good evening to Professor Dr. Abdullah bin Haji Yassin. So for today, we are from group 16, are going to present about the alternative assignment project for our group. The product that we have chosen is steering wheel. I am Muhammad Nahidat bin Jamat with matric number 72439.
My name is Muhammad Azmil bin Adam with number matrix 723448. For introduction, this project aims to test and apply our knowledge on the manufacturing process involved in making a product. Manufacturing process is important when making products. A manufactured product begins with raw materials that will then undergo a flow of pattern of processes by Pakjan and Smith 2010. The product chosen by our group to be analyzed is a car steering wheel. Steering wheel is the most important aspect of a car. There are several manufacturing processes involved in making a steering wheel, and they are casting process, joining process, metal forming process, and non-metal forming process. Objective. First, to choose the process for casting process, joining process, metal forming process, and non-metal forming process to create a model of steering wheel. Then, to know more about the process of making materials or products. Next, to learn about processes and functions is process in manufacturing. Then, able to learn and try to create a model using the manufacturing process. Then, an ability to design manufacturing process that result in products that meet specific material and other requirements. Last, an ability to acquire and apply new knowledge as needed using appropriate learning strategies.
So this is the flowchart of making the steering wheel for our product.
First method to produce manufacturing process of steering wheel is called forging process. Forging process by screw and rivets. The method of shaping of rivet and or screw without heating the material is known as cold forming or cold heading. This is done by heating or pressing the part against a foam or die to achieve the desired dimensions. More than one strike is frequently needed. Cutting the slugs, lubrication, and forging operation are three processes of cold forging. Is for reason for using cold forging process. High efficiency material utilization or high yield. Then cost reduction to customized manufacturing process and high production rates and long die life.
So the first component that needs to be manufactured for the steering wheel is the armature. This armature is made using cold chamber die casting process, and it functions as the internal support structure of the steering wheel. So the armature is made of magnesium due to its lightweight and strong characteristic. So first, the mold of the armature is made from iron due to it high resistance to corrosion and thermal fatigue. Then the magnesium metal are heated until 650 Celsius to achieve the molten state. Next, the molten metal is poured into the injection chamber using ladle, and the hydraulic plunger will force the metal into the die at high pressure. The plunger then holds the metal until it solidifies in the cavity. After solidification, the die casting machine ejects the casting from the mold, and a robotic arm moves the casting to the cooling area and cool it down using cold air. Then the excess metal on the casting is removed using a trimming die. The reasons for using cold chamber die casting process is because they provide excellent dimensional accuracy and surface finish. It also can provide high production rate and reduces the cost of production due to the less amount of finishing operation needed. Next phase is the assembly phase. 4 rivets are installed into the steering wheel, and they act as the contact points of the horn system by completing an electrical circuit when the horn is pressed. Then, a computer-guided engraver marks a lot number on the armature for quality control tracking. In this case, the rivets act as the component of the steering wheel.
Then process injection molding is used to create polyurethane foam. When the two chemicals that made up polyurethane is flexible full skin polyether, polyol, and MDI type isocyanate are mixed together, they react, resulting in us expanding the foam. The reaction occurs within a mold and the dense foam takes on the form of steering wheel. The mold is coated with a release agent before ejecting the polyurethane to prevent the foam from sticking to the mold. It is often sprayed with protective paint that dyes the foam the desired color, which is usually black. This is the picture of injection molding. Then, the reason for using injection molding process. First, fast production and highly efficiency. Next, good color control and large material choice. Then, product consistency. For trimming operation, the flywheel has an excess of polyurethane due to the injection molding process. So the next step is to trim it. Flexible full skin polyurethane foam steering wheels have a soft feel and come with a wide range to surface, texture, and color. This is the picture of trimming production. Finishing production. Finishing making for sinks to of steering. Mold out plastic machine then cut with metallic paint for high-end look. For molding a steering wheel, the mold is formed with a first cavity for forming the ring and second cavity arranged therein in a slide core for forming cooling members.
So next, the switches wiring assembly process begin. After the structure of the steering wheel is completed, the switches are installed. So the switches are assembled into the finisher, which is functioning as the housing. The wiring of the switches are assembled into the wire harness and connected to the switches. The switches and its wiring are then installed into the steering wheel by using mechanical fastening joining process. The reason for using mechanical fastening process is because it is the assembly and transportation, disassembly and maintenance, and the manufacturing of the process. Besides, it reduces the overall cost of the manufacturing of the steering wheel. Next, the quality control phase begins. The workers check the switches for its functionality. If they function properly, the assembly is marked with a barcode sticker to indicate that it passes the quality control test. The wires are then routed through the steering wheel to prepare for the final assembly.
For final assembly, install the springs mechanism to stabilize the airbag module, allowing it to shift in and out when the horn is sound. Then place the ground wire in the wire harness in the desired location. Then install a back cover made of plastic resin. Last, joining process using threaded fastener by using screw against to complete the final assembly. Okay. Final inspection. Final quality control inspection using robot arm with camera. The steering wheel wrapped in leather and often extra swift controls for the audio system.
So this is the picture of our finished product, which is the steering wheel. So there are many defects that normally occur in the cold chamber die casting process. So one of it is gas porosity, which is caused by the trap gas inside the molten metal. So the method to minimize this defect is by vacuum degassing. at which the magnesium metal is molten into the vacuum. In the vacuum. The next defect is hot tears, which is caused by thermal contraction or incorrect metal pouring temperature. To minimize this, provide appropriate fillet edge junctions of the armature, or use accurate metal pouring temperature, which is 650 degrees Celsius for the magnesium metal. Next, flash, which is caused by the molten metal filling parting line of the die and solidifies. So it can be minimized by die matching, at which we inspect the deviation in the die design and then correct the design. So another defect is sinks. They are caused by the short cooling time of metal or not enough metal supplied to the mold. It can be minimized by increasing the cooling time of the metal or by pouring extra molten metal into the injection chamber. So the next is defect in mechanical fastening joining process. So one of the defect is cracks, which is caused by the excessive amount of stress at joints. The method to minimize this is by applying sufficient stress to the fasteners. Another defect is dents, which is caused by the excessive amount of stress or the deformation of the material, which is the housing. The method is the same, which is by applying sufficient stress to the fasteners. So another defect is the scratch marks, which is caused by the contact of the screw with the soft surface of the housing. To minimize this defect, we place the fasteners, which is the screw, carefully into the hole during the joining process.
For defect cold forging process. First, flex that this form of forging flow occur when the forged product is not properly cooled. When cooling is done properly, flex can be stopped. Then, cold shut that when the metal flow at different temperature meet, they do not weld completely. The fillet radius of the die is increased. This forging defect can be avoided. The surface cracking carry out at a low temperature, causing cracks to appear on the workpiece. It can be controlled by maintaining a constant temperature. Then, defect injection molding. First, warping. That when different sections of components shrink unevenly, it can cause deformation in injection molded products. To minimize this, ensure the cooling process is gradual and long enough to prevent uneven stress on the material. Then, sink marks. Sink marks are often caused when the cooling time of the cooling mechanism is sufficient for the plastic to fully cool and cure while in the mold. To minimize is reducing the thickness of the thickest wall section will also ensure faster cooling and help reduce the likelihood of sink marks.
For this part, we will focus on the design consideration. In cold chamber die casting process, one of the consideration is the selection of casting process, which is it is chosen because it provides excellent dimensional accuracy and surface finish, and also it provides high production rate. So another consideration is the design of the cast part. It is important to consider the finishing operation needed. Another consideration is establishing good practices, which is the quality control operations. For the mechanical fastening joining process, one of the design consideration is the type of loading. Besides, size and spacing of the holes needed also need to be considered by using standard size and avoid making holes near the edges or corners to prevent tearing. Another consideration is fastener material. We need to use a compatible fastener material so that it can be compatible with the material of the component, which is the housing. The number of fastener used need to be considered too by using minimum number of fasteners.
For design consideration, call forging process. First, lubrication. That the use of high viscosity oil in cold forging is important for reducing bare metal to metal contact. Then annealing. Annealing soften the material and reduce the flow tension, allowing for smoother material flow. Then material volume. If closed forging is used, the billet size must be precisely regulated. When excess material is compressed in a closed die cavity, there is no way for it to escape. This may result in extremely high stress inside the die, putting the tool at risk of serious damage. Then, for design consideration, injection molding. First, material option and consequences. Material are often mentioned early in the design process and all parties can agree of them. Molders will be able to get large amounts of particular resins at a significant discount. Customers will benefit from these discounts. Then, uniform wall thickness of the design consideration. Most injection molding materials do not respond well when they are forced to flow across wide thickness differences.
So the next part is optimization. The way we can optimize the cold chamber die casting process is by using simulation. In this simulation, we can detect possible defects on the casting, allowing us to select the best mold design to reduce the possible defect before the production process begins. This can reduce the cost of reduction. This can reduce the cost of production. So the second one is mechanical fastening joining process. To optimize it, we need to investigate the sufficient stress amount that should be applied to the joints without damaging the components before the production phase begin. So another method is by planning the number of fasteners in the hole's position. So this can minimize the use of fasteners.
Focal forging process optimization. First, simulation. The primary methods for achieving consistent product quality, long-term life, and high accuracy are examined. Using finite element simulation, will find the best interference value for achieving compressive stress in hard yet fragile inserts under real forging loads. Simulation also produces a profile die shape with compensate for tooling set elastic deformation and ensures precise geometrical accuracy of the forged component. For optimization of injection molding, first, quality control or sample creation. Although quality control is an important part of the overall molding manufacturing process and is normally done after the part have been manufactured, quality control for sample part is a little different. First hand look at how the full process will go by evaluating part quality, sort size, mill temperature of the actual batch of resin that have on hand, and more by evaluating a sample production process of small part run. Mold testing and evaluation that examining the functionality of mold as it interacts with the material they choose to use will also help to optimize the molding process. For conclusion, for manufacturing process, first for casting process, the method die casting was chosen, and for joining process, the screw used to connect the structure to the steering wheel. Then for metal forming process, the screw forging used to cold forging method was chosen, and for non-metal forming process, the injection molding process was chosen in manufacture the steering wheel. Then we can learn an ability to design manufacturing process that result in products that meet specific material and other requirements.
And that is all from us, Group 16. Thank you.
Thank you.